Today we're taking a look at section 12.1 on visual displays of data. And in this first section here of chapter 12, which introduces us to statistics, we have a number of vocabulary words at the beginning. So I want to take a look at those before we actually move on to looking at the visual displays, commonly called graphs. Population is the grouping of all items of interest that are under discussion. The sample would include some of the items of interest, but not all. Descriptive statistics is the process of collecting, organizing, summarizing, and presenting data. It also can refer to the numbers themselves, but we'll primarily use it to mean the process. And inferential statistics is where we draw conclusions from the data we collect. Now, what we find is that we have two types of data, two basic types. Quantitative is numerical in nature. Let me get my pen working here. All right. Quantitative is numerical. Qualitative is non-numerical in nature. Okay, so let's look at some examples I have here so we can take a practice some of the vocabulary. Whoops, I don't want to go that far. Here we go. Okay, the professor studied the letter grades of all of his students from the semester. Is this a population or a sample? And is the data quantitative or qualitative? Okay, so we're talking about letter grades, and a key word is all. Those are the primary words that we're going to focus on as we determine the answer to the questions. So part A, is this a population or a sample? I look at the word all, and that tells me it's a population. If he studied only a sampling of or selected a few, then it would be a sample. But since he's studying the letter grades of all of his students, that would be a population. Is the data quantitative or qualitative? The letter grades tells us it is qualitative, not quantitative. Remember, qualitative data is non-numerical, whereas quantitative data would be numerical. Okay, let's move on to example number 2. A computer is used to randomly select 100 students from the current GCC students. Each one is asked to tell how many miles from campus he or she lives. A histogram is made showing the data, and the mean distance is computed. Okay, so is this a population or a sample? All right, so the key word for this, randomly select 100 students. That tells us it's a sample. And the question is how many miles he or she lives from campus, and we're using a histogram. How many miles would be quantitative, would be a number. Would this be considered descriptive statistics or inferential statistics? This will be descriptive statistics at this point in time. Okay, we have a third example. A professor studies her two Math 151 classes. One class is an online homework program. In one class, a homework program is piloted, while the other class continues to do homework from the book. The numerical grades from the two classes are compared to see if there's a significant difference between the final numerical grades in those two classes. The professor tests the hypothesis that the grades in the class with online homework will be significantly greater than the grades in the other class. Is the data quantitative or qualitative? Well, since the professor is comparing, and let me pull this back down so we can see hopefully both. the numerical grades. So that would be quantitative. Would this be considered descriptive or inferential? Once we begin doing a test, a hypothesis test in this case, that would be inferential statistics. We're trying to infer something about the population from the data that we've collected. Now, there are four important characteristics of data. As we go through this chapter, we'll talk more about these. A center is a representative or an average value that indicates where the middle of the data is located. And we're going to learn there are several types of centers. Variation is a measure of the amount that the values vary among themselves. Distribution is the nature or the shape of the distribution. And we'll talk about different types of distributions. And then outliers are sample values that lie very far from the vast majority of sample values. Okay, so that basically is our introductory information in terms of vocabulary, so that we can move on to talk about our graphs or visual displays of data. And you can say data or data, it really doesn't matter. So data with frequency distributions. The first type of table or visual display we talk about is a frequency table or a frequency distribution. What we have in a frequency table is, it is a table. We have a list of classes of values along with the frequencies of those values that fall into each class. And in the classes we find we have a lower class limit and an upper class limit for each class. So we have a smallest number and a largest number for each class. We also have class boundaries, which are halfway between the upper limit of one class and the lower limit of the next class. We have class midpoints, which we find the middle point between the lower class limit and the upper class limit. And finally, we have the class width, which is the difference between two consecutive lower class limits. Now, in many cases in our book and in the exercises in my math lab, they give you the class width, so you don't have to worry about figuring that out. But if you're doing a frequency table on your own, you need to be able to figure out a way to come up with a decent class width. So the way you do that is you take the highest value minus the lowest value in your data, and then you divide by the difference, that difference by the number of classes you desire. And in frequency tables, the number of classes should be somewhere between 5 and 20. I rarely see one that has 20 classes. Most of them have like 5 to 10, I would say is much more common. When you get this number where you divide the difference by the number of classes, regardless of what the answer is, you want to round it up. If you don't round it up to the next highest value or to a convenient value, failing to round up may mean that one data value won't fit into your table anywhere. So be aware of that. Okay, and so we have a few things we need to be aware of as we construct frequency tables. Number one, we want to be sure that the classes are mutually exclusive. That means that each value should belong to one and only one class. They should not overlap. We need to include all the classes even if the frequency is 0. We should try to use the same width for all classes. We want to select convenient numbers for the class limits. We use between 5 and 20 classes. The sum of the class frequencies must equal the original number of data values. So I have an example that I constructed, and we're going to look at this, and then in the next recording we'll take a look at some of the graphs we can make from this data. Here are the final exam grades from one of my classes. Let's look at the frequency table I constructed and identify the different parts of the table. Alright, I'm showing you how I calculated my class width right here. And notice that my high grade was a 90 and my low grade was a 64. That was a difference of 26. So what I did was I decided on 6 classes, and I got the answer of 4.3. And I decided it would be more convenient to use a 5, which is what I get when I round 4 up to the next largest number. So I decided to start with 60, and so the way I do it, because my class width is 5, the next class would start with 65, then 70, 75, 80, 85, and I need one for 90. Now you may note 1, 2, 3, 4, 5, 6. I was thinking 6 classes. Because of the fact I started with 60 and not 64, I actually ended up with 7 classes. But I need to make sure I have a class for every single value. Okay, then what I did was I went through the table, and one way you can do this is to use, and let me go back to my ink tools here, and 86 appears. Use what I call tally marks. 81, 76, 64, 81, 89, and so forth, doing tally marks until you have gone through the entire list. And then once you have the tally marks, you simply count how many you have, and that's how I came up with the frequencies that are listed here. Notice I added the numbers to check and see. There were 30 exam grades. Now, a relative frequency table, instead of just the frequency, what it has is the frequency divided by the total number of values, and change that to a percent. Let me make sure. Yes, that's the way some of them use the decimal and some use the percent. So I take 1 divided by 30 and I get 3.33%. 3 divided by 30 is 10%. 3 divided by 30 is 10%. 9 divided by 30 would be 30%. 8 divided by 30 is 26.67%, and so forth. Midpoints are found by adding 60 plus 64 and then dividing that sum by 2. So I came up with 62. 65 plus 69 divided by 2 is 67. What you'll notice is the class width appears here again. It's a difference of 5. So once I get it established that yes, it's coming out the way it should be, I just simply add 5 down the list. Okay, now the boundaries will be halfway between 64 and 65, gives us this one. So we add the 2 and divide by 2, we get 64.5. Notice that the same number ends the first set of boundaries and begins the second one. When we use this on the histogram, we use these for graphing. Sometimes the midpoints are used for graphing, okay, or the boundaries. And the midpoints are also used when we do frequency table calculations. So between 69 and 70, we would have 69.5. Again, notice how it's duplicated. We want to go a half a step before 60, so that would be 59.5. And we want to go a half a step after 94, so that gives us 94.5. So we have a frequency table, and I actually included a lot more in this table than typically is done. And they'll use, typically you might just have these 2 columns, or you might have the first 3 columns. You won't be seeing the midpoints and the boundaries, but I just wanted to include those simply because those are important when we get to the graphs. So in the next recording, we'll look at some examples of graphs that we can make using this frequency table and doing some other problems.